Welcome everybody. This is a new unit. It's called Redox and Redox Reactions. We're going to be briefly going through this as a quick introduction to the process of reduction oxidation. So let's get started. So where do we find redox reactions? We can actually find them a lot of different places. So there's a couple things here on the list that we might not know about that are actually redox reactions are responsible for. For example, the rusting of metals, which is a very slow process, but it is caused by by a redox reaction. Photography, so in terms of developing photos, that is also a redox reaction. You can see there's a whole list of them. There's just a few of them here. One of the things that we're going to be focusing on this unit is the operation of a battery. So a battery works on redox reactions, and we're going to be looking at what kind of redox reactions are responsible for them, how it can be spontaneous, and how we can also reverse it to electroplate things. For example, electroplating certain metals with gold and using them from consumer uses. So first we have to define what a redox reaction is. And redox stands for reduction oxidation, as we can see right over here. Okay, reduction oxidation, we get our red and we get our ox. It involves the transfer of electrons. This is the important point, that it actually transfers electrons. We have to have two species, one that's losing electrons and one that's gaining electrons. So if we have species here, we have to have that transfer of electrons for this to actually happen. Well, okay, so in this case, when we look at this picture over here, we can define this species here and this species over here. The species that actually is losing the electrons, this species is undergoing oxidation. Okay? And the species that's gaining the electrons, or becoming more negative, this one's becoming more positive, is called reduction. So when we look at oxidation, it is basically defined as the loss of electrons, and reduction is the gain of electrons. Now, it doesn't matter how many electrons it gains or how many it loses. If it loses electrons, it is called oxidation. If it gains any certain amount of electrons, it is called reduction. Now, what's a little bit confusing for some people is that something that is becoming oxidized, so in this case, this species right over here that's being oxidized, this is also called a reducing agent. Why is it being oxidized, but is also called a reducing agent? Well, to answer that, we have to remember that these two processes, this process of oxidation and reduction, always occur together. You can't have oxidation without reduction. So for something to be oxidized, that means it has to lose its electrons. Well, where does it lose its electrons to? It can't just go up in the air. It has to lose its electrons to something, to the species that is being reduced. So what an oxidizing agent does is that it forces the other species to become reduced, to gain electrons. And so this species that's undergoing oxidation is also called a reducing agent because it's forcing the other species to gain electrons, thereby becoming reduced, allowing itself to lose its electrons and thereby becoming oxidized. So what that means for the species that is being reduced, well, the species that's being reduced is called an oxidizing agent. And the reason for that is because if this species that is being reduced is forced to pick up electrons, well, it has to get electrons from somewhere. Well, this other species. It's forcing this other species to become oxidized. So the species that is getting reduced is the oxidizing agent. And so here we have a little graphic of what's actually happening. And here what we have is this species with an electron, and you can see when we compare it to the other side of the arrow, it's lost its electron. So we call it an electron donor, and if it loses electron, that means it's being oxidized. Okay? Now, this species over here, the one in green, it's picking up an electron. We can see that the electron's being transferred over. So what this species is it's becoming reduced, or it's undergoing reduction. All right, now, if this species is being oxidized over here, that means it has to lose its electrons to the species that's being reduced. So in essence, this species that's being oxidized is forcing the reduction of the other one. So this is also our reducing agent, and on the flip side, this is our oxidizing agent. And you can see that when this process happens, there is a transfer of electrons. That's the point of the whole redox. There's a transfer of electrons, and the species that was reduced now has an extra electron, and the species that was oxidized now has one fewer electron. And this is just a little brief photo of what is actually happening. So again, a reducing agent, it loses electrons because it's oxidized. It reduces the other one, which means that it gains electrons, it's reduced, and it's also called the oxidizing agent. So there's some ways that we can remember what oxidation and reduction is. There's two mnemonics that are usually used. One of them is oil rig, and as you can see, OIL, oxidation is loss of electrons, that is. Okay? So when we talk about oxidation, you're losing electrons. And same thing, reduction is gain of electrons. So you're gaining electrons, you're becoming more negative. Here, you're losing electrons, you're becoming more positive. So we can use oil rig if you want, or you can also remember using it Leo-Gur. So in this case, we lose electrons, that is called oxidation. And if we're gaining electrons, that is reduction. So again, if we are gaining electrons, we're becoming more negative. If we're losing electrons, we are becoming more positive. So this is just a kind of brief overview of what I spoke about before regarding the relationship between the species that's being oxidized and the fact that it's a reducing agent, and the species that's getting reduced and the fact that it's an oxidizing agent. So once again, for something that's being oxidized, it has to lose its electrons to something. That thing has to, the other thing, whatever that might be, that is species, has to become reduced. It has to gain those electrons. So the species that wants to lose its electrons, the species that wants to be oxidized, has to be a reducing agent. It has to force the other thing to become reduced. It has to force them to pick up the electrons that the oxidizing agent is losing. And so that means that we cannot have an oxidation reaction without a reduction reaction, and vice versa, we can't have a reduction reaction without an oxidation reaction. So they always occur together. That is the key point. Okay? We can't have one thing losing electrons if something else won't pick it up. Okay? Now, when we look at this, we can actually take a full reaction and split it up into half reactions. Okay? So usually what we see is we see something like A plus B with some kind of charge will result in A plus and B. Now what we can do is we can actually split this reaction up into two half reactions. So in the reduction reaction, we'll talk about this more a little bit later. In the reduction reaction, it means that the species, the reactant, is picking up electrons. It's gaining electrons. So if we see this, let me just make this a little bit clearer. This is a positive. If we see this, what we're seeing, well, let's take a look at these species over here. Here, this is a normal, just regular species. It doesn't have a charge on it. And if we look what's happening on the other side, it's become positive. Well, if it's become positive, how does it become positive from having no charge at all? Well, to become positive, that means it has to lose electrons. So if A is losing electrons, well, that means that it's being oxidized. So A is becoming positive. Now, because it's a positive 1, how many electrons has it lost? Well, it's gone from a charge of 0 to positive 1, so it's actually lost 1 electron. So that means that B must be the reduction. So B must be gaining, and so it is, because here we see a positive charge, and here we see no charge at all. So it's become less positive. The only way that it can become less positive is by becoming, or picking up an electron, becoming more negative. So B, positive, had to pick up 1 electron to become B. So here what we see, and this is a very simple example, but we see two half reactions. We see the reduction reaction where B is becoming more negative by picking up an electron, gaining an electron, it's being reduced, and A is actually losing its electron and becoming an ion, so thereby it's becoming oxidized. So if we add these together, our electrons should cancel out, which they do, and we'll get our original formula like this. So if we add, again, if we add both half reactions, we should get a full reaction. Now again, the important thing that we mentioned before was that redox reactions is all about the transfer of electrons, which is very, very important to us, because if we can harness that transfer of electrons, we can get some work done. Okay? So if we take electrons, and let's say we put a light in that wire where the electrons are flowing. Well, now what we can get is that we can get light. And this is all about electrochemistry. It's about harnessing those electrons that are being transferred. By harnessing those, we can put them to work and we can make some electricity, or why we name it electrochemistry. So again, where there's an oxidation reaction, there's a reduction reaction, because for something to lose electrons, something else needs to gain electrons. Okay? And we're going to be talking about oxidation numbers to help us with this concept later. So here's just a brief little graph, a little diagram, just to help us out in understanding what everything is happening. So in this case, the oxidizing agent is being reduced. It's being forced to pick up these electrons and become in a reduced state. Our reducing agent is going to be oxidized, which means it's going to lose electrons to the oxidizing agent. And in that process, it itself becomes oxidized.